All right, it's recording. So exercise 1A was add, subtract numbers. Exercise 1B is now looking at multiplication and division of numbers. So let's have a look here. There's a couple of terminologies that is nice to know, especially if you are interested in mathematics. The theory is quite intuitive, but not to all people. Let's start with the first one. They say it's called a commutative law. What does commutative law mean? It means that order doesn't matter. Fill that in, please. Order does not matter. Now, order doesn't matter for only two operations out of your four typical ones. So you've got plus, minus, times, and divide. Which of the four, there's only two, which two, where order does not matter? You can add say, when I say order, I mean like 6 plus 3, and then 3 plus 6. Doesn't matter which way you write it. Versus say like 6 minus 3, and then 3 minus 6. Doesn't matter which order you write. Which two operations? Doesn't matter about order. Yes, Jacob? Plus and times, very good. Plus and multiplication are the two that it doesn't matter about the order. So in the example I wrote here, 2 times 3 times 4 doesn't have to be in that particular order. 2 times 3 is 6, and then 6 times 4. So the answer should be 24, and you can see here, I can still write it as 4 times 2 times 3. So I changed the order, but we know that 4 times 2 is 8, but 8 times 3 is also 24. This is called commutative, because the order doesn't matter. This is important once you start working with letters and not numbers. So for example, in algebra, if we say A times B, the reality is that B times A is actually the same thing as well, because order doesn't matter. That will confuse some students, but if I wrote it as numbers, 2 times 3, does not matter because 3 times 2 is the same. That's what they're trying to say. Okay? All right. So order doesn't matter for addition and multiplication, but it does matter for subtraction and division. So when you're dealing with subtraction division, make sure to write the numbers correctly. It does mean differently if you write 6 take away 3 and 3 take away 6. A lot of students who aren't really strong with subtraction and negative numbers, they often write that. Okay? There's a difference between the two. All right, next one. Associative law means that grouping doesn't matter. So you learnt back in year 7 and your previous years. Sorry, you shouldn't be having on your laptop at the moment. You should be writing notes. So actively listening or actively taking notes. Keeping an eye on you now. Ollie, laptop down, thank you. Okay, so doesn't matter. What does that mean? So when you learn BODMAS, there are sometimes we group things with brackets. So here, 2 times 3 times 4, even if I grouped 2 times 3 and I put them in brackets, associative means that you can also associate the brackets with other groups. So actually, I can still write it as 2 times bracket 3 times 4, and this would also still be the same answer. So if you did 3 times 4 first, that's 12. Double of 12 is 24. Here, if you did 2 times 3 first, which is 6, and 6 times 4 is still 24, this is called associative. Okay, so it means the grouping doesn't matter. Now, similarly, which two operations work? It's plus and times. Those are the two that order doesn't matter, and hence associative is also working as well. Okay? And then finally, distributive. This one helps you to identify that you can actually do some multiplication sometimes mentally without doing the algorithm. And this is one of the other ways that you could do it. So I'm going to show you. It means that you can multiply groups of place values. So what do I mean by that? Notice this is a 9. That's units. 73 is made up of 2 different place values. 73 can be written as 70 plus 3. Correct? So you got 7 tens and 3 units. So 73, I've just wrote it differently. So what am I saying here? I'm saying 9 times 73 is the same thing as saying 9 times, let's break that apart, 70 plus the 3. Okay, why did I put brackets around them? Because you need to add these two together first, so they become 73, and then 9 times 73. Now, why is it called distributive law, or distributive law? It's because sometimes doing it in our head, if you tried to do 73 times 9, it's a bit hard to do it in our head where we're like, 9 times 3, 27, carry the 2, 9 times 7, 63, add the 2. That takes a lot of effort to do. But what's easier is that since you know there's 7 and a 3, and it's broken up into tens and units, you can use what we call a distributive law, which means it's 9 groups of 70. So right here, 9 groups of 70, so 9 times 70, plus 9 groups of 3. See, 9 times 3 is easy. These two we know. So you can do this in your head. So you can do 9 times the 3, which we know is, what's 9 times 3? 27. So we know that's 27 over here. And then 9 times the 7, but remember that's 7 tens. So you can actually think of it as the 70, 9 times 70. Now 9 times 70 we know because we know what 9 times 7 is and add on the 0. What's 9 times 7? Take your time. 63, add on a 0, and that's 630. And in our head, it's much easier to do 630 plus 27 because 30 with an extra 20, that makes it 50 plus a 7. That's right, that's 57. So you get your answer 657, which is exactly the same as what I did over there. That's an algorithm. Some of you are really good with your mental game. So some of you can visualize numbers really well in your head. Most of us may find that hard. This is another method. This is called breaking it apart, choosing easier numbers. So you can do 9 times 3 is 27. You can keep that in your head. 9 times 70 is 630. You can do 630 plus 27. And then you can figure it out. It's much easier than doing an algorithm for some people. Okay? So that's called distributive law. Those are just some terms there. Okay? Yep, just copy down whatever the notes are. And if I'm going too fast, remember all of this is on OneNote. You can always go back onto your laptop and then follow it. And if you weren't here, you can still watch this video, okay, because it's currently recorded. Yeah? All right, let's move on to the next example. So here it says mental strategies in estimation, very similar to exercise 1A. Mental strategies, this is one of the mental strategies you could use. You could use any other way, but I'm just showing you one of the ways, yeah? So let's do, if you did 5 times 160, there's many ways here. I don't care which way you choose. You can do the algorithm, you can do a distributive law, or you can make up your own. I don't care. You just got to show me your method. So I saw some of the homework that students have posted from the Year 8 level, and I'm seeing students skipping the steps here. What I want to see is when you're doing your homework, I do want to see the problem. This is the problem. So the problem is 5 times 160. Then I want to see the method. What are you doing? Now you can use the algorithm. That's method 1. You can use distributive law. That's method 2. Or you can make up your own. You could do 5 times 16 and then add on a 0. It's up to you. I don't really mind, but you have to show me your method. Yeah? So here, what I would like to do is I like doing distributive law. It's easier for me. Yeah? So in my head, this is the same thing as saying 5 times 100 plus 60 plus 0. So if I did it in my head, what I'm seeing is that you can see what I'm doing. See, I didn't just write the answer. I'm showing you what I'm thinking in my head. Distributive law says you can do 5 groups of 100. That's easy. What's 5 times 100? 500. So I already know in my head that's 500 plus 5 groups of 60. Yes, very good. 5 groups of 60 is like saying 5 times 6 and add on the 0. 5 times 6 is 30. Add on the 0. 300 plus 5 groups of 0. Well, it's just 0. So really, in my head, all you have to do is 500 plus 300. What's the answer? Close. 800. Okay? So that's a mental strategy. But what am I showing you? I'm showing you the problem, the method, the answer. In your exercises, I want to see for every single question, there's a question, method, answer. Okay, I need to see what you're thinking. Here's an example of my Year 12, who I haven't had a class with, so I haven't taught these guys, but look at their layout. If I go to my Year 12 book, let's pick the student that actually uploaded their work. It was, who was it again? I think it was this person. If you look at their work, can you see the layout? I haven't taught them yet. I haven't seen them because we've had interruptions so far. So tomorrow's our first session. But they've got a problem. They've got the method before they get to the answer. They didn't just write 2A, 1 solution. A lot of these you can actually see through just by looking at it. But you can see the student is following a particular method. This is how you're taught in mathematics by the time you get to senior levels. Every exercise requires a problem, a method, an answer. Someone should be able to follow your thinking and get to where you get to. The reason why is because by the time you get to senior level, the mathematics is not something you can just look at and say what the answer is. So therefore, if you make a mistake, you don't know where it is if you don't write out your working out. Your working out is proofreading. That's how you lower your mistakes and increase your accuracy. So there are some students that I know, they keep saying when they look at their test, like, oh, I made a mistake here. Oh, I could have got 80% because I just didn't see this, I didn't see that. Often it's not a mistake. It's often habits. Bad habits build bad results. So if you want to be better at your results, even if you know your technique, the layout is key. Top 2% in the state in mathematics is not students who actually just write the answer. It's the students who have a clear layout. So I've never seen a student who's in the top 10% of the state, if they want to do really well in year 12 in mathematics, who do not have this kind of layout. Never seen it before. So hence, at your level, you're only in year 8. You've got 4 years to develop. If you carry on to any mathematics level, layout is key. That's why when it comes to your homework, I'm more interested in your layout and not the answer. I don't care about the answer. I gave you the answers already. So if you go back to your textbook, your OneNote, see that tab there? It says textbook solutions. If you click on it, you literally have the solutions laid out for you. I put it out for you. So I'm trying to encourage you to learn your mistakes and work through it. I don't care about the answers. I care about your method. You got to learn to lay it out. I promise you, even if I leave the answers there, most students still don't copy it because they're too lazy. Okay, because students who don't want to put in the effort, doesn't matter what I do for them. The amount of resources, videos, and PDFs and answers, it's the fact that they just don't want to do. Okay, so I'm encouraging you now, if you want to do something, then it's you. It's not the teacher, it's not the subject. If you always think maths is hard, it's really just about taking a step forward and trying every single day. Okay? So I'm here to encourage you to take responsibility rather than blame your teachers or blame the subject or blame whatever it is. There's no blaming. It's about accountability. Yeah? So here we go. Let's go to the next one. Example 2. 232 divide 4. Here, there's a lot of different ways that you can do. We can do short division. You can break it up into multiple numbers if you like. It's up to you. I normally just do short division. So here in my head, I'm doing 2, 3, 2. And in my head, I'm thinking, how many 4s fit into 2? How many 4s fit into 2? 0. It's too small, so you take the next 2 digits. How many 4s fit into 23? 5. But remainder what? 3. So you carry the 3 over to the next digit. Now that becomes 32. And how many 4s fit into 32? 8. Very good. And this is where times tables will be important. If you're not strong on your times table, it's okay. Take your time. Some of your exercise books on the back, there's the times tables chart. Use it. There's no shame in it. It's about learning. Right? So how many 4s fit into 32? It is 8. So the answer is 58. I want to see this. Method. I don't want to see the answer. I can do that in a calculator. You can do it on a calculator, but I'm interested in this. How did you get there? Okay? All right. Make sure to copy that down. And now we're on to the next 2 techniques. Do I have another page? Yes, I do. I'll leave that for you to do. Here we go. 412 times 13, and the other one's 951 divided by 4. For those who aren't strong with multiplication or aren't sure how to do the algorithm, here we go. I'll show you how to do it. And you might need more practice with this for some students. I found in year 8. How do we do it? We write them in their columns, so units with units, tens with tens, hundreds with hundreds, and we start off with the units here. Okay, so 3, you're going to do 3 groups of 2, 3 groups of 1, and then 3 groups of 4 individually. So let's take our time. What's 3 times 2 equal to? 6, very good. So you write down 6 as your first digit. Then you do how many 3s? 3 times 1. What's 3 times 1? 3. Remember, this is 3 times 110, so that's why it's in the 30. So that's 36. And then 3 times the 4, which is really like saying 3 times 400, 12. And that's why 3 times 400 is 1,200. That's why you're getting 1,236. Now the next step, this is where sometimes I see mistakes come from year 8s. The 1. Students will then do 1 times 2. Now what's 1 times 2? 2. But students will write the 2 here. Remember, that's the tens column. It's not 1 unit, it's actually 1 tens. So when you say 1 times 2, it's actually 10 times 2. So it should be 20. Okay? So for your technique, make sure to put a 0 here. You start in the second column. Make sure to write the number in the second column. Don't write it in the first column. Next one. 1 times 1. What's 1 times 1? 1, very good. So we put it in the next column. That's like saying 10 times 10. That's why it's in the hundreds. And then lastly, 10 times the 400 or 1 times the 4. 4. Now we can add them all together. Units, 6 plus 0 is 6. 3 plus 2 is 5. 2 plus 1, 3. And the last one, 5. This is what I want to see when you're writing your questions. I need to see question, method, answer. QMA. Okay, so for every exercise, if you're doing question 2A, I want you to label it. What's the problem? What's the method? And then what's your answer? So it's QMA. Okay, every student that I teach will follow this method. Okay, I need to see what you're thinking. And remember, the answers are already in the OneNote. If you're having troubles, you can always go back and have a look at how they did it and learn from it. There's no reason to quit. Next one, 951 divided by 4. Let's go and do this one now. This is our last example for today. The one in the back, you can have a go at your own pace. I will write the solutions up, but these are the only 2 techniques that you want to learn in this session. Here we go. Short division, 951 divided by 4. The 4 always goes on the outside. Here we go. Let's take our time. How many 4 fits in 9 can I please have? Let's learn some names again. Let's go with Charlotte. How many 4s fit into 9? 2. What's the remainder? 1. So we carry the 1 across to the 5, and that becomes now 15. Right? Rather than just 1 unit, it becomes the next one, which is now 15 tens. So we've got 15 tens there. Then we say, how many 4s fit in 15? Can I please have, let's go with Ryan. How many 4s fit in 15? 3. So 3 times 4 is 12. So what's the remainder here? Let's go with Attila. 3, very good. So we carry the 3 across. It's not 1 now, it's 31. And your last one is, how many 4s fit into 31? Can I please have Adele? 7, very good. It's close to 8, but 8 is 32. 4 times 8 is 32. So that's a bit smaller. So you have to go down 1, so it's 7. 4 times 7 is 28. And this is 31. So what's the remainder? Close. 3. 28 and 31. It does feel like 2, but it's 3. So then you write remainder 3. Okay, so 237, remainder 3. That is your answer. That's it for today's lesson. Exercise 1B's multiplication division. You're working with short division and long multiplication. I'm going to write the answers for the back side, but I want you to have a go with that first and then work on your exercises. Everything that you don't finish in class is homework, but the task for the end of this week is exercise 1A.